Now let us look at the register file model. So as I said earlier, register file model is a modification upon the memory subsystem model. So memory is when we talk about the memory, it is a memory of the whole system, whereas register file you can conceptualize as a very small amount of memory, very fast in nature by the way, resides inside the central processing unit. Okay, resides inside the central processing unit, whereas your memory is reside outside the central processing unit. From a physical system point of view, if you open up a computing system and look at the motherboard, you will see there is two distinct, at least two distinct component. One is your CPU, central processing unit, which is a processor like a Pentium or MIPS or ARM or something else like Snapdragon, etc., etc. And there is the memory, right? Memory card, for example. Memory card is a bunch of memory devices stacked together or connected together there, but there is this two subsystems clearly visible on the motherboard. One is the processor and another is the memory. Now this register file is kind of memory, but it stays inside the central processing unit or your processor. Okay, so that's the difference, and it has a very special functionality, and it's actually derived out of the memory model. We can easily derive it out of the memory model. Implementation is completely different at the hardware level though. So so register file is, let's see, it has a 32 register of each of them 32 bit, 32 register of 32 bit each. Okay, so you can think of this is a memory, have a 32 rows, 0 index 0 to 31. Okay, and then it has a read and write, it has an address. Since you have only 32 rows, you only need 5 bit to index them. To represent a value of index between 0 to 31, you need just 5 bit. We'll review that in our number system study. Okay, and it has reset, it has a clock just like memory. Only difference is that in case of memory, there is one single data bus which is in and out in nature. Like for a read operation, it acts as an output signal. For a write operation, it acts as an input signal. But in case of register file, there is two distinct separate signals: data out 32 bit, data in 32 bit. So here, from timing diagram perspective and also operation perspective, one thing we just eliminated, I would say one difficulties we faced in the memory subsystem we eliminated just is, for the memory system, it was not possible to make a consecutive read and write operation. Right? Remember, we need to have at least one cycle gap between once you initiate a read, and after that, if you want to initiate a write, you need to have one cycle gap, right? With separating data bus into two, like a data in and data out, we just eliminated that problem. Okay, now it is possible you initiate a read signal, read request between time t2 and t3, and immediately after that you can request a write operation, which will not create a problem. Why? Because see, since our data out, this level is missing by the way, I think, yes, there is a data, this is a data in. Okay, this is the data in. So this data in, okay, so you are presenting the write data onto a completely separate electrical signal compared to your data out, right? So your read operation will write into this data bus, data out, right? So your read initiation will send out a data in the data out, whereas your write is sending rest of the system in sending the data to the registered file, which is nothing but a memory, a type of memory, into the data in bus. So there is no conflict, and we just resolve that problem, that issue of not being able to give a write request immediately after a read. Okay, so this one point, it is faster. Okay, there are various other point why register file, though it is a memory, but it's much faster than a traditional memory just we talked of in the last slides. Okay, so this is one difference. Okay, now we modify. So one step we modified, right, from here, from this model to this model, right, and then we make more modification. Let's see. Now, since there is only limited number of register, like 32 register, we only need like 5 bits for addressing and stuff like that. So we have a possibility that we can read out two rows at a time. And by the way, these rows, like as I said, the memory is nothing but you can think of a table with rows. For a register file, these rows are called a register. Okay, it's a distinct hardware device, by the way, and they are called, each row is called a register. Okay, so here we are now transforming from a simple register to a little complicated register, where we can actually do two read operation in parallel. Okay, I can read out two of this row together in one clock cycle. So I will present R1 first register address, second register address, read to 1, write to 0, and both of this data from both of this location will appear in two of this 32 bits, R1 data out, R2 data out. Okay, and of course there is a write address. We don't want to write it together. There is no point in writing values together in two different register. So now at this point you may want to ask why it is a matter that we want to read two register at a time. Let me explain this. If you look at your arithmetic and logic operations, most of them are binomial operation, right? They involve two operands, like a plus b or a multiplied by b, a and b, a or b, right? There are two operands involved. These register files are stored, are used to store operands temporarily. Okay, we'll see later. Okay, this conception, just hold on to this thought for time being. Just take it as a granted that this register file temporarily stores operands into it, and when this computing system wants to retrieve these operands and send it to ALU as two of the operands there, if we can access both the operands simultaneously, then it will be beneficial for us for a faster operation. Why? Imagine, like, if we want to use this registered file instead, and both my operands are stored in the registered file, to send it to the ALU, what do we need to do? One read followed by another read, and then only we can initiate the initiate the ALU's operation, right? So we need two cycles there, right? Read for operand 1, read for operand 2, and then perform the arithmetic operation or logic operation. With this hardware, it is possible that I will read or retrieve the operand 1 and operand 2 simultaneously from this component and send it to ALU. So I just save one clock cycle right there, right? So this is a boost in performance. All right. So this is what your modern system, most of the systems register file looks like. Okay, it is nothing but a memory, very small amount, only 32 storage of 32 bit, okay, and it resides inside central processing unit or processor, whatever you want to call it, okay, and it has capability of parallel read, okay. So far we'll later also see in the semester that we'll then configure this to have parallel write as well, right? We can read from this register file simultaneously while we are writing back a result into the register file.